Since we've been working with radicals, now it is time to look at what the square root function will look like. We are already pretty familiar with f of x equals x squared, as that's the parabola we've been working with in quadratics for a few weeks. We're going to actually use that and compare it to what f of x equals x squared would look like, and see if we can find any similarities. At this point, we probably don't even need to fill in our table in order to graph because we know of our pattern, but we're going to use their values here to compare to our values here and see if we see any similarities. So we can fill it in 1 squared, 2 squared, 3 squared, 4 squared, and so forth. I probably should have mentioned you're going to want a calculator for the other side. The square root of 0 is 0, the square root of 1 is 1, the square root of 4 is 2, and the square root of 9 is 3. So I skipped quite a few in between simply because those aren't perfect squares. So we can use the calculator to get a decimal approximation. If I gave you a minute, go grab a calculator, and then go ahead and find the square root of each of these numbers. I'll give you a few minutes to do so. Hopefully you got the square root of 2 is about 1.4. The square root of 3 is about 1.7. The square root of 5 is about 2.2. For 6 it's 2.4. For 7 it's 2.6. And for 8 it is 2.8. I want you to ignore the points with the decimals. What do you notice about the other points? I found this question kind of confusing, but if we really look at what we have 0, 0, 1, 1, 4, 2, and 9, 3. So ignore the rest of them, and then come back and look at the x squared function. Do you see any similarities? I have 0, 0 again. I have 1, 1 again. I don't have 4, 2. I have 4, 16, but I do have 2, 4. And I don't have 9, 3, but I do have 3, 9. So what do you notice about the points? Hopefully you see that at some of those points that we have listed here, the x and the y are reversed from each other. The x and y values are reversed. Mathematically, these functions are called inverse of each other, and by definition, this means that the x, which we know as our domain values, and the y values, or our range, are switched. You'll learn a lot more about inverse functions in the future. Alright, so let's go ahead and plot the points on the tables above. I'm just going to use what we know our rule is. 0 over 1, up 1, over 2, up 4, 1, 2, 3, 4, over 1, up 1, over 2, up 4. So I have my parabola. If I graph these, I'm just going to graph my whole numbers because I can just do a basic sketch and get a good idea of what the graph would look like. So 0, 0, 1, 1, 4, 2, 1, 2, 3, 4, over 2, or up 2, and then over 9, 6, 7, 8, 9, 1, 2, 3. As a result, the graphs have the same numbers in their points, and hopefully you kind of heard me say it. I went over 1, up 1, over 2, up 4, but over here, I went over 4, up 2. So if you can think about that a little bit more, you're just looking at how there are patterns that we use to graph quadratics are still going to be able to be used. They're just going to have to be switched. As a result, the graphs have the same numbers in their points, but the x and the y coordinates have switched places. This causes the graphs to have the same shape, but to be blank over the line blank. And you got to go all the way back to the unit we did on transformations. Whenever we reflected over a certain line, the x and y values would flip. And if you can go all the way back to that, you would see that these two functions are going to be reflected over the line y equals x. If I look at the square root function a little bit further, because this is only half of a parabola, and why might that happen? Down here, I could see my parabola when y equals x squared, or f of x equals x squared. If I was to graph the parabola and I was to reflect it over the line y equals x, it would look like this. And if you think back to my title or what I just said, the square root function, why would that pose a problem? If you think about the vertical line test, and I pass my pen along, it's not going to pass the vertical line test. So if I was to use that as my graph of y equals the square root of x, that wouldn't anymore be a function because it does not pass the vertical line test. So we're going to have to define the square root function, because we want it to be a function, as the square root of x squared is only using the absolute value of our x. So really, if you think through what this means, we're just saying we just want the principal square root. We don't want both positive and negative. This means we will only use the positive side of the graph or the top side of the graph. We're going to move on to page 7. We want to make sure that we have some key characteristics of the graph established. The vertex of our basic f of x equals the square root of x function, the vertex is at 0, 0. End behavior is kind of interesting. I've been doing some of my own independent research on the best way to show you what end behavior looks like. And different places will tell you different things. We're going to just make sure we have a consistent language in our classroom, and it's pretty consistent with what the high schools will be doing. You're going to be using this a lot more once you get into pre-calculus and calculus as you look at the limits of functions. The end behavior, if we just describe it, the left side stops. So there's no arrow. That's actually where our vertex is. The right side increases towards infinity. And since it's going up from left to right, that would be an increasing graph. We're actually going to describe it slightly differently once we get to true examples. And I guess I could show you right here, right now. We're actually going to say there's no left end behavior. What some teachers will do will say that as x approaches negative infinity, y does not exist. I think no left end behavior probably describes it a little bit better. And then as x approaches infinity, so that means as I move to the right towards infinity, y also approaches infinity. Our domain values start at 0, and it's going to go to infinity. We can write that in interval notation. 0 is included, and it goes to infinity. The range is going to be very similar. It's going to be 0 to infinity. Unlike our parabolas when we did quadratics, there is no symmetry because we are only using the top portion of the graph. Even though I held out on you for a long time with quadratics teaching you the pattern, now we're going to be able to use the pattern right away. So our pattern before was over 1, up 1, over 2, up 4. Now it's going to be over 1, up 1, over 4, up 2.